हेलो हेलो हेलो। वेलकम वेलकम वेलकम। तो एक नई लाइव में फिर से स्वागत है। पिछले 2-3 दिनों से लाइव नहीं हुई है और वहीं पे अटका हुआ है मामला। जो मेरा एल्गोरिदम का जो सीरीज़ है, या बोल सकते हो जो मैं कंप्लीट कर रहा हूँ प्लेलिस्ट, वो वहीं पे अटकी हुई है। तो मैंने सोचा आज थोड़ा सा समय मिला है तो आज कर लेता हूँ। एक्चुअली दिक्कत ये है कि बहुत दिनों से मतलब कुछ काम आ गया है जो मेंटली मतलब थोड़ा सा वैसा है, क्या बोलते हैं, ब्रेन स्टॉर्मिंग बहुत ज़्यादा करनी है उसमें। तो इस वजह से मैं थोड़ा सा उस तरफ ध्यान दिया था। मेरा काम मतलब उस पे आया है, वर्क प्लेस पे थोड़ा समय ज़्यादा लग रहा था। समय नहीं, लेकिन मेंटली तुम ज़्यादा वहाँ अवेलेबल थे, क्योंकि एक चैलेंज है उसको आपको पूरा करना है। तो इसी वजह से मैं नहीं कर पा रहा था लाइव्स वगैरह ज़्यादा। ज़्यादा क्या यार, 2-3 दिन की बात है, तो 2-3 दिन हो गए हैं नहीं किया, जबकि मैं सोच रहा था कि मैं हर दिन लगभग 1 घंटा या 45 मिनट्स अराउंड लाइव करूँगा। तो वही थोड़ी सी इनकन्सिस्टेंसी हो गई है, जो कि यूजुअली होती है हर चीज़ में। मैं पहले ही बता चुका हूँ, ये लाइव स्टार्ट करी थी मैंने उसी दिन बोला था कि मैं लाइव स्टार्ट करने का जो मेरा मेन मोटो है वो यही है कि यार मैं बहुत ज़्यादा इनकन्सिस्टेंट हूँ व्हेन इट कम्स टू लर्निंग ऑल दीज थिंग्स। दैट्स व्हाई आई हैव स्टार्टेड दिस लाइव सेशन। और हाँ, तो हम लोग लास्ट उसमें हम लोग पढ़ रहे थे क्या, लास्ट उसमें हम लोग पढ़ रहे थे ग्रीडी एल्गोरिदम के बारे में, ठीक है। और हम लोग नैपसैक प्रॉब्लम का ये पूरा पढ़ चुके थे, तो एक बार फिर से रिवाइज कर लेते हैं। बेसिकली ग्रीडी एल्गोरिदम क्या है? इट्स एन अप्रोच फॉर सॉल्विंग प्रॉब्लम्स। तो इसमें हम लोग ऑप्टिमाइजेशन प्रॉब्लम सॉल्व करते हैं, आइदर मैक्सिमम और मिनिमम रिक्वायर्ड होता है। जैसे एग्जांपल के लिए एक पाथ है, मतलब तुमको एक प्रॉब्लम है, ए टू बी जाना है, ठीक है। इसके मल्टीपल कंस्ट्रेंट्स भी हो सकते हैं और मल्टीपल पाथ्स भी हो सकते हैं जाने के लिए। जैसे कंस्ट्रेंट में ये आ गया कवर विद इन 12 आवर्स, तो आपको 12 घंटे के अंदर जो पाथ है ये कवर करना है। और दूसरा कंस्ट्रेंट हो सकता है कि फेयर लिमिटेड कर दिया है, ये सारी चीज़ें। तो ये हमने पढ़ा था। ऑप्टिमल सॉल्यूशन की बात करें तो एक ऐसा सॉल्यूशन विच इज सेटिस्फाइंग कंस्ट्रेंट्स एट द सेम टाइम, this is the best minimum or maximum of all the feasible solutions. The feasible solutions means all the solutions which are satisfying the constraints, given constraints. And the optimal solution is the most optimal one within those set of feasible solutions. तो उसको बोलेंगे ऑप्टिमल सॉल्यूशन। ओके, अब आ जाते हैं ऑप्टिमाइजेशन प्रॉब्लम। ऑप्टिमाइजेशन प्रॉब्लम में रिक्वायर्स आइदर मिन मैक्स रिजल्ट्स, ठीक है, हाँ। The strategies to solve optimization problem is greedy method, branch and bound, and dynamic programming. So currently we are studying about greedy method. इसमें क्या होता है, हम लोगों को बेसिकली अगर देखें तो हम लोग सारे सॉल्यूशंस में जाते हैं, मतलब सारे सॉल्यूशंस में जाके चेक करते हैं क्या ये सॉल्यूशन फीजिबल है, कंस्ट्रेंट्स को सेटिस्फाई कर रहा है। अगर कंस्ट्रेंट्स को सेटिस्फाई कर रहा है तो हम लोग उसको सॉल्यूशन एक मतलब एक फीजिबल सॉल्यूशन में ले लेते हैं, नहीं तो नहीं लेते हैं। फिर आ जाता है रादर देन गोइंग थ्रू ऑल द सॉल्यूशंस टिल द एंड वी एलिमिनेट सम सॉल्यूशंस व्हिच डोंट सीम टू बी फीजिबल। हाँ, क्योंकि इस केस में क्या होगा, तुम ग्रीडी एल्गोरिथम का मतलब वही हुआ ना कि तुम केवल वही पहले से ही तुम केवल उसी पाथ को चूज कर रहे हो, या तुमको पता है कि यार जैसे अब तुमको 100 रुपये दे दिए जाए और तुमसे बोला जाए कि तुमको यहाँ तक जाना है। अब तुमको पता है कि प्लेन की टिकट महंगी होती है यूजुअली, और वहाँ तक जाने के लिए पैसा लगेगा, तो तुम क्या चूज़ करोगे? तुम मतलब पता होगा ना, तुम बायस है कि भाई प्लेन की टिकट महंगी होती है इसलिए तुम उधर नहीं जाओगे। आ जाते हैं अब नैपसैक प्रॉब्लम के ऊपर। तो भाई नैपसैक प्रॉब्लम यही थी कि कुछ ऑब्जेक्ट्स दिए हुए थे, उनमें ऑब्जेक्ट्स का प्रॉफिट दिया हुआ था और आपको वेट दिया हुआ था हर ऑब्जेक्ट का, और आपको एक बैग दिया हुआ था जिसकी कैपेसिटी 15 है। आपको क्या करना था, आपको मैक्सिमाइज करना था किसको, प्रॉफिट को, ठीक है। कंस्टेंट्स ये है कि कंस्टेंट्स दो थे। तुम्हारा कंस्टेंट था कि तुम्हारा जो वेट है वो रहना चाहिए विद इन द मैक्सिमम कैपेसिटी ऑफ योर बैग, and your objective was to maximize the profit. Profit is that's xi and pi, means the like amount of object you carried with you and the profit tied to that particular object. And this is not just the amount, this is the like amount per kilogram or something. तो यहाँ पर इस केस में हमने क्या किया, इसमें दो चीज़ें होती हैं, या फिर तो डिविजिबल होते हैं ऑब्जेक्ट या फिर तो डिविजिबल नहीं होते हैं। तो उस केस में हम लोगों ने क्या किया, सबसे पहले निकाल लिया था पी वाई वेट यानी प्रॉफिट वाई वेट यानी यूनिट वेट का प्रॉफिट निकाल लिया था। फिर जिसका यूनिट वेट का प्रॉफिट ज़्यादा आ रहा था सबसे पहले हमने उसको पूरा पूरा ले लिया था जितना भी लेना है। उसके बाद में धीरे से हम लोग आगे बढ़े थे। और ये देखो प्रॉफिट हमारा आया था, ये हमारा वेट आया था जो कि 15 kg था। ठीक है, इसका दूसरा भी एक सिनेरियो होता है जब यहाँ पे केवल जैसे 2/3 आ गया ना, यहाँ पे 2/3 नहीं आएगा क्योंकि डिविजिबल नहीं होंगे, तो केवल 0 या 1 आएगा। चलो फिर स्टार्ट करते हैं।
Are included. There is one more problem called 0-1 knapsack problem. That is
चल जाओ भाई।
hi. Our next problem is job sequencing with deadlines. This problem we are going to solve it using greedy method. So first of all, we will understand what the problem is. Already I have an example. Through an example, we'll understand what the problem is. Then we'll see how to solve it using greedy method. So let us know about the problem. See, here in example, 5 jobs are given. 5 tasks are given. And if that task is completed, we will get this profit. So associated with each job, there is some profit. But that job must be finished within this deadline. It must be completed within the deadline. Like first job should be completed within a deadline 2, and deadline job 2 also 2, job 3 is 1. So like that every job is having some deadline. So the problem is jobs are given, every job is having some profit, and if you complete the job, you will get the profit, and you have to complete that job within a deadline. Now let us understand what all these means. Assume that there is a machine. On that, each job has to be processed. Each job takes 1 unit of time for completion. This is the assumption. This is the assumption in the problem. Right? So what is this 1 unit? I will assume this as 1 hour. So on a machine, each job needs 1 hour for its completion. So you can take an example like a DTP operator, or see, mostly for making legal documents for on a bond paper. You will find people in the market who will prepare documents. Suppose that preparation, you take the job. So he's a typist, right? And he completes each job in 1 hour. That's it. So that example you can take. Now, what is the situation? Let us understand. See, assume that in the morning he has opened the shop. The moment he has opened the shop, these 5 people are standing there for getting their jobs done. All right, so you have to take this situation to understand the problem. And each person is having his own deadline. He is saying that I want my job to be done first, in first hour only. Can you do it or not? If you can do it, do it. And this person is saying that I am ready to wait for 3 hours. No doubt my job needs only 1 hour, but I am ready to wait for 3 hours. Suppose it's morning 9 o'clock, so he is ready to wait till 12 o'clock, and he is ready to wait till 11 o'clock, and he is ready to wait till 10 o'clock. So whose job should be done first? This job should be done first. But what is the profit we are getting? If this job is done, let us say this is rupees, and we get just 10 rupees. And if this job is done, then we get 20 rupees. So obviously, which job should be done first? Highest profit job should be done first. Yes. Now the problem is, we want the set of those jobs which can be completed within their deadlines such that the profit is maximized. The profit is maximized. So there's a maximization problem. And what is the constraint in the problem? Job must be completed within the deadline. Alright, so this is suitable for greedy method because it's an optimization problem, it's a maximization problem. So we can apply greedy method. Now let us solve this problem using greedy method. Let us see how we can apply greedy method. So first of all, how many hours are available for that typist to complete the
and we get the profit as maximum, and we get the profit as maximum. ओके ओके। मैं यहाँ पे थोड़ा सा एक और चेंज करता हूँ, सीन स्विच करने का मैं थोड़ा चेंज करता हूँ, हॉट कीज लगाता हूँ। स्विच टू सीन, यस, इंट्रो सीन टू नहीं है ना अभी, क्या ये सीन टू है। स्विच टू सीन टू के लिए मैं लगा देता हूँ कंट्रोल शिफ्ट टू, ठीक है। और स्विच टू सीन वन के लिए लगाता हूँ कंट्रोल शिफ्ट वन, ठीक है। ट्राई कर दो, ओके, कंट्रोल शिफ्ट वन करो, ठीक है।
job. See, one of the person or two people are ready to wait till 12 o'clock or for 3 hours they are ready to wait. So after that nobody is there. Suppose this is the only jobs that he has when he has opened the shop and he has to complete this within their deadline. How many slots he is having? From 0th hour to first hour, 1 unit of time. In this hour he can complete one job. Then first hour to second hour he can complete second job. And second to third he can finish third job. So it means nobody is ready to wait beyond 3 units of time, 3 hours. So he has to finish jobs within these 3 slots only. If I give the time, this is 9 o'clock to 10 o'clock, and this is 10 o'clock to 11 o'clock, 11 to 12 o'clock. Now there are only 3 slots. How many jobs he can do? Deadlines are giving just 3 slots, so he can do only 3 jobs. Out of 5, he has to select just 3, so that the profit is maximum. Now, if we apply greedy method, then on what basis we will select the objects? We will select the objects in the order of their maximum profit. So first maximum profit, then next maximum, and so on. So let us see how to solve this one. Who is having highest profit? This one. So you can see already that the jobs are already arranged in the decreasing order of the profit. So I have to consider them in the same order. This is having highest profit. Now I will select this job for completion. I will select it. I will not perform it. But in which slot I should do? He is ready to wait for 2 units of time. Means he came at 9 o'clock. He is ready to wait till 11 o'clock and his job needs only 1 unit of time. So let us do it in this slot. Now let us pick up the next job. Second highest profit is 15. And what is his deadline? 2. Now again go to 1 to 2. He is ready to wait till 11, 2 units of time, but this is already occupied. Now see if there are any slots available on this side. Yes, it is available. So that job too here.
Sir.
Now let us select the next job. Third job here. To wait till 11, 2 units of time, but this is already occupied. Now see if there are any slots available on this side. Yes, it is available. So that job too here.
Okay.
Now let us select the next job. Third job. Its deadline is 1. Can we do it? Let us see. 1 means what? 0 to 1 within this one. No, this slot is already gone. So this job is rejected. We cannot do this job. So we have selected already these 2 jobs. Then what about this job? This can be done because the deadline is 3. So he is ready to wait till 12 o'clock or third unit. And every job needs 1 unit of time. Remember that. So we will do this in this slot. So that's it. And what about this job? Third, already occupied. Is there any slot free on this side? No. If there is no slot available there, you can look for the slots in this side. So there is no job slot available.
Okay.
That's all.
So what I understood from this is that you first select the job which has the topmost profit, and then you do it at the end of the deadline, just so this one can could wait for 2 hours. That's why I was doing it in second slot. So because it would only require 1 hour and I would be done by the time this deadline hits. And now this one is allocated. Now comes the second one. So because what we can think, how we can analyze, make an intuition about it, is that suppose this job is very necessary, right? This job is very necessary because we want to maximize the profit, and it's the job which is giving you the maximum profit. Then so you really want to finish it just before the deadline. That's why you put it just before the deadline. So this is the intuition, and I don't know whether it would be applicable for all the cases or not, but currently as my understanding says that it should be applicable to most of the scenarios. Let's see. we'll find out.
Solution. What are the jobs that we are going to do? We are going to complete jobs 2, then job 1 and job 4. And in which sequence we have to do them. So here, both the jobs are having deadline 2, so we can do them in sequence J1, then J2, then J4, or else J2 to J1, then J4.
So
We can complete them
sequence,
in any of these
okay,
sequences.
so
These are the
sequence,
sequences possible for completing those jobs as both are ready to wait for 2 hours. Total profit will be, this job is 20 and this job is 15,
15,
and the profit
that
of this
would
job is 5.
5.
So it is 20 plus 15 plus 5
40.
is 40.
Okay,
So the total profit that we gain will be
40.
Now let us solve this. Here I have taken table. Now initially there is nothing, and there is nothing in the solution, and the profit is also 0. Let us start. First, which job we will consider? Job to be considered. First job, I'll write 1 or J1. First job I am considering. And first job, as the deadline is 2, we will assign a slot from 1 to 2. 1 to 2. You remember we have the slots from 0 to 1 and 1 to 2 and 2 to 3, because the maximum deadline is 3 here, so these are the slots available. Now, solution. As this is included, we have allotted this slot, job 1 comes into this solution. And what is the profit? 20 is the profit. So this first job is included. Then consider second job. Okay, J1 I'll write, J2. Can we assign a slot to this second job like J1 was here? Yes, J2 can come here. So we will assign a slot from 0 to 1, and already 1 to 2 was already assigned to this one. So already 2 slots are over, you see. And we have the solution J1 and J2. How much profit we have? 20 plus the profit of the second job is 15. So this is 35. I am just keeping it as it is. Now next job to be considered, J3, third job. Its deadline is 1. 0 to 1 already occupied. So no slot is assigned and everything remains the same, and the jobs are J1 and J2 only, and this is 20 plus 15 only. So this job is not included in the solution. Now next job, J4. J4. So we can assign a slot. 0 to 1 is already gone, 1 to 2 is already gone. J4 can be done in slot 2 to 3. So this is J4. So here we have 2 to 3. And the solution is having J1, J2. Job 4 is selected and it is 5. And job 5, it cannot be selected. So this remains same, this remains same. And this total will be 40. Total will be 40. I have taken one more problem for solving this using greedy method. It's a problem for job sequencing with deadlines. We have to follow greedy method. So we decided that we'll select the jobs in the decreasing order of their profits, and that's how we may be getting maximum profit. But the constraint is they have to be finished in a deadline. So how many deadlines are there here? What's the maximum time we have to submit any job? Maximum time a job
तो
can be
अगर
submitted is
इसमें
4.
देखा जाए, मतलब
So
इसमें
how many
ग्रीडी कैसे लग रही है, अगर ये पता किया जाए तो हमको मैक्सिमाइजेशन मिनिमाइजेशन दे रखा है और हमारे पास एक कंस्ट्रेंट है, दैट्स ऑल. हाँ, तो उससे हमको पता चल जाएगा कि इसमें ग्रीडी एल्गोरिथम लग रही है. ठीक है, नेक्स्ट.
slots are available? 0 to 1, then 1 to 2, 2 to 3, 3 to 4. Maximum deadline 4. After that, nobody is ready to wait. The job should be completed within that 4 units of time. But every job needs just 1 unit of time. So how many slots we have with 1 unit? 4 slots we have. Now let us solve this by selecting the jobs. So the first job, what is the deadline? 3. Is the slot vacant? 2 to 3 means not beyond 3. So 2 to 3, yes, job 1 can.
So J1, J2, J3, J4 and J5, J6 and J7. Okay, the profit is 35, 30, 25, 20, 15, 12 and 5 respectively. The deadlines are 3, 4 and 4 and 2 and 3 and 1 and 2. So the maximum deadline is 4. So there are 0 to 1, 1 to 2, 2 to 3 and 3 to 4. There are 4 slots available for doing the job. So we will do more, like we will be able to do most of the 4 jobs. And how would we select the jobs to do? So whichever one having highest profit is this one. So and this one would wait till 3, so we would complete it here. And the another one, this can wait till 4, so we can do it like this. This also can wait till 4, but because we have already filled that particular slot, so this one is done, this one is done, so we can allot it this slot. This one is also done, and now currently this, so we would allot it this slot. I think that would be the answer. J2, J1 and J3, J4, and the sequence can be changed a little bit because both the J2 and J3, yep, J2 and J3 can be interchangeable, and yeah, that's all. I think J1, J2 can also be interchangeable, and J3 and J4 can also be interchanged because for J4 the deadline is 2, and in both of the cases, if J3 is there or J2 is there, the deadline of both would be 2, but means both, like the deadline of that particular slot is 2, so we can also put J4 there. So what are the combinations? Combinations would be J4, J3, J1 as this one written here, J2, and the another one would be J3, J4, J1, J2, and another one would be J4, J2, J1, J3, and the another one would be J2, J4, J1, J3. These 4 sequences would be correct answer.
Can be done.
Or feasible,
and we got the profit 35. I'll write this below.
Feasible or optimal answer.
Then next job, J2. Deadline is 4. So check 3 to 4. Yes, it's free. It can be done. So J2 and the profit that we got is 30. Then J3.
प्रॉफिट भी तो है, तो J1 में हम लोगों को 35 मिला,
No, 3 to 4 is
J2 में 30 मिला,
Then check this side if it can be done
J3 में
early.
हमको मिला है 20 और फिर इधर 15 मिला है.
Here, yes.
तो अगर ऐसे देखा जाए तो
See, this
5
means
इधर
that this
20,
person is
40,
ready to wait for
40 और
4 units
60,
of time.
100
So
100 हो
4
जाएगा
hours.
प्रॉफिट.
We can finish it early also. We don't have to do it in 3 to 4 slot only. We can finish it early also. No doubt he is ready to wait. But that slot already we are doing it for somebody else. So let us bring that one here. So this third job can be done here.
The logic is same
his profit
as
is
I told,
35.
as we like made
Now,
that
J4,
intuition
what's the deadline?
earlier.
1 to 2.
The logic
2.
is same.
1 to 2 already occupied. But can it be done early?
आपको क्या
Yes,
करना है,
this slot is
मैक्सिमम
free.
प्रॉफिट
So
वाला
job 4
जॉब
can be done
पकड़ना है,
here and his profit
फिर
is 20.
उसको उसके डेडलाइन
Now,
से
job
जस्ट
5,
पहले
job
वाले
6
घंटे में
and
पूरा
7,
करना
I
है,
even don't have
उसके
to
बाद
check them
वाली
because
को
I see that all
वैसे ही
the slots
करते
are
रहना,
already
बाद वालों को
occupied.
वैसे ही करते
So
रहना.
those jobs cannot be completed. So when we have limited slots
और इन
and
केस
we have
अगर
more
कोई
jobs,
स्लॉट लाइक किसी स्लॉट का जो डेडलाइन वाला स्लॉट है, जैसे ये जॉब है इसका डेडलाइन 3 है और 2 to 3 इज ऑलरेडी फिल्ड, तो आप एक लेफ्ट में आते हो, ठीक है.
jobs, then we have to select the job such that the profit is maximum. Final profit is, add all these, it is 110. That's all. The problem is very simple to solve, right? Once you understand the problem, then it's very easy to solve.
ठीक है, अब प्रॉब्लम भी एक बार सॉल्व करके देखते हैं. अच्छा यार, तुम लोगों को मैंने स्क्रीन तो दिखाई नहीं, ये सेम ही था जैसे मैंने किया वैसे ही सर ने किया है. प्रॉब्लम भी एक सॉल्व कर लेते हैं हम लोग. जॉब सिक्वेंसिंग विद डेडलाइंस, जॉब सिक्वेंसिंग प्रॉब्लम. लीड कोड पे करेंगे, लीड कोड पे करते हैं, लीड कोड पे करते हैं. लॉगिन कर लें भाई. मेरा लीड कोड का अकाउंट वगैरह मैंने ज़्यादा क्वेश्चंस नहीं लगा रखे हैं, तो बहुत कम से लगा रखे हैं. ये क्या हुआ, गिटहब से करना पड़ेगा क्या? मुझे याद भी नहीं है मेरे लीड कोड का पासवर्ड क्या है. मुझे लग रहा है धीरे धीरे करके लीड कोड पे भी आना पड़ेगा. हाँ, गिटहब से लॉगिन हो गया. फोटो देख रहे हो, फोटो देख रहे हो कितनी खतरनाक लगा रखी है बचपन की. So we have n jobs, okay, where every job is scheduled to be done before start time I to end time I. Okay, where every job is scheduled to be done from start time I to end time I, obtaining a profit of profit I. You are given the start time, end time and profit arrays. Return the maximum profit you can take such that there are no jobs in the subset with overlapping time range. If you choose a job that ends at time X, you will be able to start another job that starts at time X. Okay, so you are being given start time and end time. So basically तुम्हारे अभी हम लोग को डेडलाइन मिल रही थी, तो हम बोल सकते हैं कि हम लोग को स्टार्ट टाइम हर किसी के लिए 0 ही मिल रहा था और एंड टाइम हर किसी के लिए मिल रहा था। लेकिन क्योंकि यहाँ पे स्टार्ट टाइम भी मिल रहा है और एंड टाइम भी मिल रहा है, तो हम लोग को क्या करना पड़ेगा, सबसे पहले हम लोगों को मैक्सिमम प्रॉफिट वाली चीज़ों को देखना पड़ेगा। मैक्सिमम प्रॉफिट वाला आ, देखना पड़ेगा। कैसे करेंगे जॉब शेड्यूलिंग। सबसे पहले हम लोग अगर सॉर्ट कर लें इस वेक्टर को, जो प्रॉफिट वाला हमारा वेक्टर है, इसको हम लोग अगर सॉर्ट कर लें, प्रॉफिट एंड प्रॉफिट डॉट बिगिन और एंड कर लेंगे, बिगिन प्रॉफिट डॉट एंड। इसको अगर हम सॉर्ट कर लें तो इससे हमको पता चल जाए, लेकिन यार सॉर्ट करने में तो दिक्कत हो जाएगी। मैक्सिमम निकाल सकते हैं ना, मैक्सिमम नहीं निकाल सकते हैं। मैक्सिमम एलिमेंट का क्या होता था, एसटीएल मैक्स एलिमेंट इन एन एरे सी प्लस इन अ वेक्टर सी प्लस प्लस, मैक्स एल करके कुछ तो होता था, मैक्स नाम से, मैक्स आईटी। अच्छा, मैक्स आईटी की वैल्यू ऐसे निकालते थे, मैक्स एलिमेंट नाम से होता था। ये मैक्स एलिमेंट निकालो इसका, और ये तुमको एक आइट्रेटर देता है ना शायद, आइट्रेटर ही देता है, ऑटो आईटी मैक्स आईटी निकालो। ठीक है, ये तुमको एक आइट्रेटर दे देगा मैक्सिमम एलिमेंट का। अब तुमको क्या करना है, प्रॉफिट कैलकुलेट करना है ना। एट द एंड ऑफ द डे नीड टू कैलकुलेट द प्रॉफिट। सो पहली बार में मैक्स एलिमेंट ले लिया, फिर उसको मैक्स एलिमेंट को अगर मैं निकाल दूं एरे से, तो मेरे पास सेकंड मैक्स एलिमेंट आ जाएगा नेक्स्ट टाइम के लिए। और जो क्योंकि मैक्स एलिमेंट है तो मैं उसका स्टार्टिंग टू एंड टाइम ब्लॉक कर दूंगा। ठीक है, स्टार्टिंग टू एंड टाइम ब्लॉक कर दूंगा। नहीं करने पड़ रहा है, थिंक ऑन डीपी। अच्छा, डीपी का प्रॉब्लम है, डीपी तो आती नहीं है, डीपी नहीं आती है, ग्रीडी तो आती है। चलिए बाद में देखते हैं, इसको आगे पढ़ते हैं। जब सीक्वेंसिंग हो गया, ऑप्टिमल मर्ज पढ़ते हैं। चल जाओ सर।
Yeah, the problem is optimal merge pattern. Again, this problem can be solved using greedy method, and if we know how to solve this problem, we can also understand Huffman coding. So let us talk about this one. Before knowing what is optimal merge pattern, first of all we should understand merging. Let us quickly understand merging. See, if I have a list A and B with some set of elements, if I have two sorted lists, then I have to combine them and get a third sorted list. Two sorted lists are there. I have to combine them. So the process is simple. What we do is we compare the first element of each, whichever is smaller we write down that, and then we'll move to the next element and compare these two, and 5 is smaller, we write that, 8 is smaller, 9 is smaller, 11, then 12 is smaller, then 16, then 20. So quickly I have shown you the elements are compared one by one, right? So one element from each side is compared, whichever is smaller that is written here, and we get a single sorted list. So merging can be done only on sorted list. How much time it has taken for merging? If I say this is m and this is n, then the total time is m plus n. If
टोटल
in
एलिमेंट
terms of
आइट्रेट करना है ना
elements,
तुमको।
four elements, and how many I got?
8 एलिमेंट्स।
So the total time taken depends on the sizes of the list. Now let us extend the problem. What happens if I have more than two lists? Let us look at it. Now here I have 4 lists given and their sizes are given. I have not taken the elements. I am saying that this list is having 6 elements and this is having 5 elements and so on. I have to merge these 4 lists. I can merge them together also, but that will be called as 4-way merging or m-way merging. No, I want to follow 2-way merging. So at a time I want to merge only 2
only
lists.
2 lists.
So let us see how merging can be done.
तो ए या बी को लोगे, फिर उसके बाद में सी या डी को लोगे, जो 2 लिस्ट बनेंगी उन दोनों को फिर मर्ज कर दो.
11 plus 2 I'll be having 13 elements in this list.
अच्छा.
Then 13 and 3 I'll be having 16 elements. So final list altogether combined will be giving us 16 element list. Now you can see that at a time I'm merging 2 lists. But what is the total time spent in merging? Total cost. See, first I have merged 11 elements. So this is 11 plus then I have 11 merged 11 plus 2. So 13 elements, then 16. So I did not get the 16 element at once. It was in stages. So total amount of merging done is this one. So this is how much 40. Now, is there any other way I can merge? Let us try.
13 3
A, B, C and D. So this is 6, 5, 2, 3. I merge these two, 11. I merge these two, 5. Then I merge these two, 16. Yeah, I have selected a different pair every time. So what's the answer? Total cost is how much? 11 plus 5 plus 16. 2.
Oh.
Total cost is 32. Is there any other way? Let me try. There may be many possibilities of merging, but I'll try one more.
Why?
I merge from that side.
First I merge
these two. So I got 5. Then I merge these two, 10. Then I merge these two, 16. So total cost is how much? 16 plus 10 plus 5. 20, 31. Oh, I'm getting still less than that. So is there any other method by which I can get less than 31? I don't think so. See, if you see the different patterns, these are the patterns. 1 pattern, 2nd and 3rd pattern. Out of these 3 patterns, in this one I am always selecting 2 smaller lists for merging. That's why I got the minimum result. So now from this observation, we can say that the greedy method that we should follow is always we should merge a pair of small size lists to get the best result. Yes, so we have the greedy method now. We got the approach for solving this problem. We understood that always you select 2 small size lists, combine them, then total merging time will be reduced. If you follow like this, then the time was 40 and this was 32 and there is 31. So that is best one. Alright, so we'll take one problem and solve that one.
Okay.
Here's an example problem for...
so this means, इसका कितना था? इसका 40 कुछ था ना? इसका 40 था.
Optimal merge pattern. Alright.
इसका 40 हुआ, इसका हुआ टाइम है ऑफ 40 हुआ, इसका हुआ ऑफ 32, इसका हुआ ऑफ 31. ठीक है, तो यहाँ पे जो ग्रीडी होता है, ग्रीडी अप्रोच बोलती है कि तुमको क्या करना चाहिए. ग्रीडी अप्रोच बोल रही है कि यू शुड मर्ज टू स्मॉलर list first, then move on to next smaller and merge it with previously merged. यही तो बोलना चाह रहे हैं.
So we'll take one problem and solve that one. Here is an example problem for optimal merge pattern. I have 5 files, x1, x2, x3 to x5 are file names, and these are the sizes, number of elements in each file. Now we'll follow greedy approach for solving this one. We have to find out a pattern in which the total cost of merging is minimized. So let us follow greedy method. Greedy method says that you should always select a smaller pair of files for merging. So they are not arranged in the increasing order of their sizes. I will take them in increasing order of their sizes. 5. I have taken those files in the increasing order of their sizes. Now let us follow optimal merge pattern. So we should select a smaller pair of files and merge them, 5 and 10. So I'll merge these two. I'll get a new file of size 15. Then what are the files I have? I have a new file of size 15, 20, 30, 30. Now which one is smaller? I should select a pair, 15 and 20. These two are smaller. So I should select these two and merge them. So this is 35. 15 plus 20, 35. So after merging these two, I'll be getting 35 elements here. Now what are the list I have? 35, 30, 30. So I should select a pair of minimum size list or least size list. These two. Merge these two, that is 60. Now what are the list remaining? 35 and 60. Combine these two and form a list that is 95. Now let us find out what is the total cost of merging. See, first these two files are merged, the cost was 15, and when these are merged 35, so I should take the sizes in these circular notes. So the sizes are 15 plus 35 plus 95 plus 60. It is 205. So the total cost of merging these files by following a optimal pattern is 205. I have added all these internal notes and I got that result. Even what I can do is, how I can know the cost is, this file, how many times it is merged? 1 time, 2 time, 3 time. So the number of time it is merged with the file says depends on the distance. So let us call this as a distance. So distance is how much? 1, 2, 3. So 3 times, what? 5 plus 1, 2, 3. 3 times 10. 3 times 10 plus 1, 2. 2 times 20 plus 1, 2. 2 times 30 plus 1, 2. So 2 times 30.
समझ गया.
So I have taken their distances and their sizes. Even this total will also be 205. If you multiply and add all these things, it will be 205. So how I can know the total cost of merging? Either by adding the sizes of internal nodes or these nodes, external nodes I can say, external nodes with their distances. So here I can say it's like a formula, distance of each node di with the size of each node xi. So this gives the total cost of merging for all these files by using optimal merge pattern. That's all about optimal merge pattern. The problem is very simple, but this is used by Huffman coding. So the next video will be about Huffman coding.
Huffman coding, Huffman coding, Huffman coding, Huffman coding. Uh, 35 minutes are over. So let's see. Huffman coding पे आ गए हम. अरे अच्छा, ये तो मैंने देखा है यार. ये इसका तो सवाल था, अभी थोड़े दिन पहले ही मैं कर रहा था, लेकिन हुआ नहीं था मेरे से. देखना पड़ेगा. चलो भाई.
The topic is Huffman coding. Huffman coding is a compression technique. It is used for reducing the size of data or message. Suppose you want to store the data in a file, so you can store the data in compressed form to reduce the size of a file. When the data is sent over a network, data can be compressed and sent to reduce the cost of transmission. In this video, I am going to explain you if a normal message is sent, what will be the cost, and what is the fixed size encoding, then what is variable size encoding, that is Huffman coding. Now let us study the problem. I have a message here. Now this message I want to store it in a file or I want to send it over a network. Then let us understand what will be the cost of a message. So the cost of this message or the size of the message will be measured in terms of bits. Let us check. First of all, there are 20 letters in this one. So the length of this message is 20. Next, how this message has to be sent? It has to be sent by using ASCII code. Electronic devices or computers all use ASCII codes for characters or English alphabet. So these are all characters. ASCII codes are 8 bits. I have used alphabets A to E here, so that is easy to understand for us. So if I say A, its ASCII code is 65, and the binary form is this one. So total 8 bits, these are 8 bits that are representing decimal 65, and that is representing A. Similarly, if I say B, then it is 66. This will be for 66. Likewise, C, D, E. For everyone, we have there is a 67 and 68 and 69, and here the binary code will be there. So 8 bits are there for each alphabet. Now, if normally this message is sent 8 bits for each alphabet, then total number of bits will be how much? As there are 20 alphabets in this message, so this will be 8 into 20, that is 160 bits. Size of the message will be 160 bits. Now, this is the simple message sent without encoding. The size will be 160 bits. 8 bits for each alphabet. Now, let us look at, can we use our own codes instead of ASCII codes? How it is possible? See, I am not using all English alphabets or all possible symbols on the keyboard. I am not using every symbol from the character set. I am using only 5 alphabets, that too capital letters. Then, do I need 8 codes, 8-bit codes for representing just 5 alphabets? No. Few bits are sufficient. So can I use my own codes with less amount of bits? Yes. So next we will see fixed size codes. Here I have taken alphabets in this message, and how many times each alphabet is appearing, I have written the count here, or you can also call it as frequency. A is appearing 3 times, 1, 2, 3. Likewise, you can check all, how many times they are appearing, I have written them here. Total there are 20 alphabets. If you want to see the frequency, then you can say this is
पानी बरस रहा है. जिम कैसे जाऊंगा, जिम कैसे जाऊंगा, जिम भी तो जाना है.
3 by 20, that is 3 by 20, or this is 5 by 20, because total number are 20, so this is 6 by 20, and you can take the ratios. I prefer taking counts, that is easy for working. Even, what should be the code? See, I have 5 characters. I don't need 8 bits for just 5 characters. 8-bit ASCII codes are for 128 characters or 128 symbols, but for only 5, let us see. If I have just 1 bit one bit, then either I can write 0 or 1. So how many symbols I can represent? How many characters? Only 2 characters. If I have 2 bits, then how many I can represent? I can write 0, 0, 0, 1, 1, 0, 1, 1. So I can have 4 different combination, and each combination can represent one symbol. But I have 5, so for that I can take 3 bits. So in this, how many combinations are possible? 0 to 7. That is 8 combinations are possible. So I will take 5 out of that. So let us say in 3 bits I will say A is 0, 0, 0, B is 0, 0, 1, C is 0, 1, 0, D is 0, 1, 1, and E is 1, 0, 0. I have given my own 3-bit codes. I will use this for encoding this message. And I will write, this will reduce the size of the message. So in me, it means here instead of writing ASCII code, I will be writing 001 for B and 010 for C. Likewise, go on. When the message is encoded using this one, then what will be the size of the message? As we know well that there are 20 characters and each takes 3 bits. So this will be 60 bits. So size of the message will be 60 bits. And one more important.
खतरनाक है भाई ये तो।
Important thing we cannot neglect. What is that? When I am sending a message, suppose encoded in this one, now how the receiver will know what are the codes?
Yep.
Even if I store it in a file and then later I want to retrieve, how do I remember what are the codes used? 00 means A only, is it? See, for making it easy, I have taken the alphabets A to E here. The alphabets can be anything. This can be A, this can be M, this can be O, this can be Q. Then how I can know which code is for what? So I should also have the codes, that is this table also, along with the message. So this is encoded message and this is the table. Use this table to decode the message. Yes. So message is 60-bit. Then you need the table also, the chart of codes that will help to decode this message. So let us see, you have to send this one also. How much size this will take? See, I have 5 alphabets. This alphabet should be in original form now. Now standard is what? ASCII code. So I must write ASCII code of all these. ASCII code of all these. So for this 8 bits. So total how many? 5. So 5 into 8 bits. This is for what? Characters or symbols. Then for each 3-bit code, for A this is the code, B this is the code, for everything I should also have the code. So total how many? 5. And how many bits for each code? 3. So this is for codes. So this makes how much? This is 40 plus 15. This is 55. And what is the size of this original message? So message is 60 bits for each code. This is for what? Is in original form now. Now standard is what? ASCII code. So I must write ASCII code of all these. ASCII code of all these. So for this 8 bits. So total how many? 5. So 5 into 8 bits. This is for what? Characters or symbols.
समझ में आ गया।
Then for each 3-bit code, for A this is the code, B this is the code, for everything I should also have the code. So total how many? 5. And how many bits for each code?
वो तो ऑलरेडी 60 बिट्स हुआ था ना, मतलब टोटल 3 बिट्स का जो कोड है उसको आप 20 फ्रिक्वेंसी टोटल आ रही थी, तो 20 कैरेक्टर्स थे, तो तुमने उसमें पहले काउंट कर लिया। अच्छा, तो तुमको अब ये भी तो बताना पड़ेगा ना कि कौन सा एस्काई कैरेक्टर कौन से कोड को शो कर रहा है, तुम्हें ये भी तो बताना पड़ेगा। तो शायद इसीलिए होगा ना। 60 बिट्स तो मैसेज जाएगा, ये तो मैसेज जाएगा, ठीक है। और एस्काई प्लस 5 हो गया ना, 5 3 15, ये जो हो जाएगा एस्काई प्लस मैसेज हो जाएगा। मैपिंग, एस्काई की मैपिंग जो होगी वो हो जाएगी, ठीक है। तो अब समझ में आया मुझको बेसिकली क्या कहना चाह रहे हैं सर। ऐसा होगा ना कि जैसे तुम्हारे 20 कैरेक्टर्स हैं, हर कैरेक्टर का 3 बिट होगा, तो उस हिसाब से 60 बिट्स हो जाएगा यहाँ पे। फिर उसके बाद में तुम्हें एस्काई कोड्स भी तो भेजने हैं ना, एस्काई कोड्स भेजने हैं, तो टोटल 5 कैरेक्टर हैं, हर कैरेक्टर का 8 बिट का कोड है। तुम्हें बेसिकली एस्काई कोड क्या, तुमको मैपिंग भेजनी है, एस्काई और तुम्हारे कोड की मैपिंग भेजनी है, ठीक है। तो यहाँ पे टोटल 5 वो हैं, तो यहाँ पे 8 बिट के 5 आएंगे, तो यहाँ पे 40 हो जाएगी। और यहाँ पे 3 बिट के 5 आएंगे, ठीक है, यहाँ पे 15 हो जाएगी। तो टोटल मिला के 55 बिट तुम्हारा जो होगा, बिट्स जो तुम्हारे होंगे हो जाएंगे इसमें। तो टोटल मिला के हो जाएगा ये 60 तो यहाँ पे था, प्लस 40 इधर हो जाएगा, प्लस 15 इधर हो जाएगा, तो ये हो जाएगा 115 बिट्स।
So this is for codes. So this makes how much? This is 40 plus 15. This is 55. And what is the size of this original message? So message is 60 bits, right? And table or a chart of codes is 55 bits. So total how much this will be? 115 bits. Yes. So total size of the message along with the chart is 115 bits. It's not just 60 bits, it's 115 bits. No doubt the size of the message is reduced, but table is also important. So it was 160, now it became 115. So around 35 to 40% of reduction in size from 160 to 115. Right? So this is one method with fixed size codes. Now we'll go to variable size code and let us follow Huffman coding, which will still reduce the size of the message. Huffman encoding. Huffman says that we don't have to say take fixed size codes for the alphabets. Some characters or alphabets may be appearing few times, less number of times, and few may be appearing more number of times. So if you give small size code for the more appearing characters, then the size of the entire message will be definitely reduced. So let us see what is his idea. Already we have this table, all the alphabets, and how many times they are appearing in the message. So that gives the frequency of those alphabets. Now Huffman code follows optimal merge pattern. Now we have to generate our own code. So what should be the method for the code? So Huffman has given an approach for getting our own variable size codes. So he says that all those alphabets should be arranged in the increasing order of their count. So this is the least one, and this is the next one, and next one, and so on. So they are arranged in the increasing order of their count or frequencies. So the first, the smallest one, then the highest one. So this optimal merge pattern should be followed on this one. So what I should do, merge two smallest one and make one node. So this is 2 plus 3, this is 5. Now next select two smallest and form a node. So 5, 4, 5, 6, these are remaining. Out of this which are two smaller, either I can take this 5, 4 or that 5, 4, so I will take this one. So I'll combine this one with this, so this is 9. Now what are the list I have, or the nodes I have? 9, 5, 6, these are the two minimum. So combine these two, this is lamb. Then combine these two are remaining now. So this one and this one. So this gives what? 20. So here we got our optimal merge pattern tree. So actually follow optimal merge pattern, that is greedy approach. Always select two minimum one, and we got this one. Now this tree will help us define the codes. How? On the left hand side edges, mark them as zeros, and on the right hand side edges, mark them as 1. That's it. Now what are the codes? For each alphabet, follow a path from root onwards. So for A, what is the code? 0, 0, 1. So A is 0, 0, 1. Then B is 1, 0, 1, 0. C, 1, 1, 1, 1. D, 0, 1, 0, 1. And E, 0, 0, 0, 0, 0, 0. That's it. These are the new codes we have. Now you can see some code is of 3 bits and one code is of 2 bits, like that. So even we may have the codes with 1 bit also. Not here, in some examples. So variable size codes are there. Now I can use these codes for encoding my message. Like B is 1, 0. C is how much? 1, 1. C is 1, 1. And A is 0, 0, 1. B is 1, 0. B is 1, 0. And D is 0, 1, 0, 1. Gone. If I use these codes, what will be the size of my message? So for that, how many bits are there for A? 3 bits. And how many times A is appearing? This is 3 into
3
3.
times.
9.
9
And
bits.
2 bits. And this is appearing for 5 times.
5
So 5
times.
into 2.
5 times.
2
2
bits.
bits.
1,
6
appearing for
times.
6
12.
So 6 into 2. 12. 2 bits appearing for 4 times. So
4 into 2.
8.
8.
And 3
3
bits
bits appearing for 2 times.
So 2 into
6.
3 is 6. So for entire message, I have how many times each character is appearing and their sizes of codes I have taken, and I got this
26
one. Now total number of bits are
36
45 bits.
and 45 bits.
Size of the message is 45 bits. Means if I encode all, I just need 45 bits. So the message size is 45 bits. Now one more thing we should consider. Along with the message, I should also send this chart or a table or a tree. Then only decoding can be done. Means along with the encoded message, what are the codes used? That should also be there. Then only decoding can be done. So somehow this tree should be preserved, or the table should be preserved. Or let's see what will be the size of the table. All these alphabets, I should send their ASCII codes, the standard code. So 8 bit of ASCII code. How many alphabets are there?
5 alphabets are there, the 40 bits.
Then codes also I should send. So these codes, when they are stored, so how many codes are there? 5 codes, but what are the number of bits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is forming 12 bits. So together, this 40 plus that 12, so 52 bits are required for a tree or a table. So what is the total size? Message is 45 bits and the table or a tree is 52 bits, and this will be 97 bits. Yes, now you can see that it is still reduced from fixed size codes. So that's all about Huffman coding. Now if you want to know the size of the message, that 45, you can know it from the tree also. How? See, this is the distance. How much is the distance? 1, 2, 3. And frequency is what? 2. So 3 into 2. So distance into frequency of each or count of each. You can take sigma, sum of all these. So this will be distance is 3 and frequency is 2, plus distance is 3 and frequency is 3, plus distance is 2 and the frequency is 4. Distance is 2, frequency 5. And distance is 2 and frequency is 6. So this is nothing but this calculation that we got, and this will be 45 bits only. So if you want to know what will be the size of the entire message from the tree also, you can find out by using this formula. If you refer a video on optimal merge pattern, you find that formula is defined. Let us see how decoding is done. This is the message now completely in the binary bits form for the message. For this, you must have a tree for decoding. So start from root, 0 left side, 0 left side, 1 right side. This is B. 0, 0, 0, 1, completed. Then again start from the root, 1 right side, again 1 right side. So reach the leaf, that is C. So these two are over. Then again, once you have reached the leaf, again start from the root, 1 right side, 1 right side. So this is C. The next 0 left side, 1 right side. It is a D. So these two are completed. In this way, this message can be decoded, and from binary bits we can get back the original ASCII code. So the receiver can convert the message into ASCII code and use it in its machine. So inside the machine, while using, it will not be using the code, so it has to convert into ASCII codes. Like when you have any zip file or compressed file, you have to decompress for using it. Same way, it should be decoded and used. So that's all about Huffman coding.
खतरनाक था भाई, खतरनाक था। तो आज के लिए इतना ही काफ़ी है। हम लोगों को हो गया है समय कितना, लगभग 50 मिनट हो गए हैं, और मिलते हैं नेक्स्ट लाइव में। हफमैन कोडिंग का थोड़ा सा नोट्स मैं नहीं बना पाया हूँ, जो कि मैं बना लूँगा। अब की बार हम लोग पढ़ेंगे कौन सा है नेक्स्ट है हमारा प्रेम्स और क्रस्कल्स एल्गोरिदम। बट बिफोर दैट आई वुड लाइक टू रिवाइज थिंग्स दैट आई स्टडीड अप अंटिल नाउ। सो रिवीजन का एक सेशन होगा जिसमें मैं अपने सारे नोट्स में गो थ्रू कर रहा हूँ, और हो सकता है अब्दुल वादी सर की वीडियोस को हाई पेस पे या स्किप कर करके देख रहा हूँ। तो ये मेरा नेक्स्ट प्लान है, और मोस्ट वेली कल ही करूँगा मैं। ठीक है, तो मिलते हैं, बाय बाय। और आज हम लोगों ने पढ़ा ये, बाय बाय, टाटा, सी यू।